Welcome to Tech with Koushik. This is set 3 of our AI-103 Microsoft Certified AI Engineer Associate Practice Question Series. Choose your answer before the timer ends. Then review the correct answer, detailed explanation, and exam tip. Keep track of your score and see how exam ready you are. Each practice set is completely standalone, so you can start here without watching any of the other sets first. Playlist link is in the description. Let us begin set 3. Review question number 86. Carefully. This question focuses on hybrid search. Let us first review the situation. A technical parts assistant searches an Azure AI search index. Users enter exact part numbers such as AX4407 as well as natural language descriptions such as high temperature seal for the feed pump. The team wants one retrieval request to benefit from both exact lexical matching and semantic similarity. Which search approach should you use? Choose from the following options. Option A is hybrid search that runs full text and vector search together. Option B is vector search only. Option C is keyword search only. Option D is image search only. The required response is Option A, hybrid search that runs full text and vector search together. This is correct because hybrid search executes full text and vector queries in the same request and merges the results, combining lexical precision with semantic similarity. The alternatives can be eliminated because B, vector-only retrieval can be weaker for exact identifiers and specialized terms. C, keyword-only retrieval can miss conceptually similar content that uses different wording. D, image search does not address the mixed text retrieval requirement. Remember this distinction for the exam. Use hybrid search when both exact terms and semantic similarity matter. The next item is question number 87. Scenario. A media knowledge base must ingest call recordings and training videos before indexing the derived content in Azure AI search. Audio should yield searchable transcripts and summaries. Video should yield transcripts, visual descriptions, and meaningful segments. In addition, the search enrichment pipeline must call the company's HTTPS service to compute a proprietary risk score for each enriched record. Which two capabilities should you use? Select 2. More than one answer may be correct. Available choices. Option A, Azure Content Understanding Audio Video Analyzers for multimodal extraction before indexing. Option B, a custom web API skill in the Azure AI search skill set for the proprietary risk operation. Option C, an image generation model for both audio transcription and risk scoring. Option D, a synonym map as the only processing step for the media files. Option E, text-to-speech to convert the indexed records back into audio before enrichment. The choices that satisfy the requirement are Option A, Azure Content Understanding Audio Video Analyzers for multimodal extraction before indexing, and Option B, a custom web API skill in the Azure AI search skill set for the proprietary risk operation. The key reason is content understanding supports audio and video inputs and can produce transcripts, summaries, descriptions, and segments. A custom web API skill extends an Azure AI search skill set with organization-specific HTTPS processing. The other choices do not satisfy the requirement because C, image generation neither extracts audiovisual content nor performs the required custom search enrichment. D, a synonym map affects query terms and does not extract audio-video content or invoke custom processing. E, text-to-speech is an output generation capability and does not satisfy the ingestion or custom enrichment requirements. A useful examination rule is this. Use content understanding for multimodal extraction and custom web API skills for organization-specific search enrichment. Let us work through question number 88. This one is marked hard. Eliminate the options systematically. Consider the following scenario. A financial services application serves a steady, high-volume workload from an Azure region inside the EU data zone. Inference data may be processed anywhere within the EU data zone, but not outside it. The application also requires reserved throughput and lower latency variance than a pay-per-token standard deployment. Which Microsoft Foundry model deployment type best satisfies the requirements? Now examine the possible answers. Choice A, Global Standard. Choice B, Data Zone Standard. Choice C, Data Zone Provisioned. Choice D, Regional Standard. The correct answer is Option C, Data Zone Provisioned. The requirement is satisfied because data zone provisioned keeps inference processing inside the selected Microsoft data zone, while providing reserved PTU capacity and more predictable throughput and latency than standard deployments. Now consider why the remaining options are unsuitable. A. Global standard can process inference data across Azure regions globally and does not provide reserved PTU capacity. B. Data zone standard satisfies the data zone boundary, but uses paper token shared capacity rather than reserved provisioned throughput. D. Regional standard keeps processing in one region, but it is paper token and does not provide the required reserved throughput. Keep this examination point in mind. Combine residency and workload shape, data zone boundary plus predictable high volume points to data zone provisioned. Now consider question number 89. Review the situation. An enterprise allows multiple teams to deploy Foundry models, but governance requires approved deployment types only and must prevent accidental use of globally routed SKUs for regulated workloads. For each statement, select yes if the statement is true. Otherwise, select no. The first statement is, Azure policy can be used to restrict which Foundry model deployment types teams are allowed to create. The second statement is, applying Azure policy makes an unsupported model become available in a region where Microsoft does not offer that model. The third statement is, Azure policy can guarantee provision throughput capacity even when the selected region has no PTU capacity available. The answer to statement 1 is yes. Microsoft documents Azure policy as a way to restrict allowed Foundry deployment types. The answer to statement 2 is no. Policy can govern resource configuration but cannot change Microsoft model availability by region or deployment type. The answer to statement 3 is no. Policy cannot manufacture service capacity. PTU availability is still constrained by quota and regional capacity. Exam tip. Use policy to restrict choices. Use availability and quota controls to determine what can actually be deployed. Let us focus on question number 90. This scenario establishes the key requirement. A team is choosing between several Foundry language models. First, architects want a fast comparison of quality, safety, throughput, and cost using published benchmarks. Before production approval, the team must validate the finalists on representative company prompts and expected outputs. Complete the evaluation strategy. Review statement 1. For the initial cross-model comparison, use the blank. The options for this statement are 1. The Foundry model leaderboard and side-by-side benchmark comparison, token usage analytics from one deployed model, or an Azure AI search index or execution history. Review statement 2. For production acceptance on company-specific behavior, use the blank. The options for this statement are 2. A Foundry evaluation run on a representative business dataset, only the public benchmark leaderboard, or a higher model temperature. The answer to the first statement is the Foundry model leaderboard and side-by-side benchmark comparison. The model leaderboard compares published quality, safety, throughput, cost, features, and related benchmark information across supported models. The answer to the second statement is a Foundry evaluation run on a representative business dataset. Public benchmarks do not guarantee performance on an organization's own prompts, so production acceptance should use representative evaluation data. Use public benchmarks to shortlist models. Use your own evaluation set to approve a model for the actual workload. We will now analyze question number 91. This question moves us into guardrail configuration. Review the scenario carefully. A regulated assistant needs 3 distinct safeguards. 1 for company-specific forbidden terms, 1 for configurable harm severity blocking, and 1 that records a supported risk signal without blocking the response. Match each requirement to the most appropriate guardrail configuration. The items to be placed are: Source 1. Block internal project code names and organization-specific forbidden phrases. Source 2. Block violence, hate, sexual, or self-harm content at configured severity thresholds. Source 3. Return a supported optional risk signal in the API response without filtering the content. The target positions are: Target A, custom block list. Target B, content filter severity configuration. Target C, annotate only mode. Target D, token usage analytics. The first mapping connects block internal project code names and organization-specific forbidden phrases to custom block list. The second mapping connects block violence, hate, sexual, or self-harm content at configured severity thresholds to content filter severity configuration. The third mapping connects return a supported optional risk signal in the API response without filtering the content to annotate-only mode. The reasoning is as follows. Custom block lists handle organization-specific terms, content filters apply harm category thresholds, and annotate-only mode surfaces supported detections without blocking. The key takeaway is block lists are lexical policy controls. Severity filters classify harm. Annotations expose signals without necessarily blocking. Proceed to question number 92. Background. Northwind publishes a customer-facing agent through a stable Microsoft Foundry agent endpoint. Current environment. Version 7 is approved for production. Developers are testing a prompt and tool change that creates version 8. Business requirements. End users must continue receiving version 7 until the release board explicitly approves version 8. The public endpoint URL must not change. Technical requirements. Agent versions are immutable snapshots. Creating a new version must not automatically change the production behavior. What should you configure? Review the options. Choice A. Pin the agent endpoint's version selector to version 7 until version 8 is approved. Choice B. Use the default always use latest policy and rely on users to avoid version 8. Choice C. Delete version 8 immediately after each test run. Choice D. Create a different Foundry project for every prompt revision. The best answer is option A. Pin the agent endpoint's version selector to version 7 until version 8 is approved. Here is the technical justification. A Foundry agent endpoint can remain stable while its version selector is pinned to a specific immutable version. New versions are then isolated from production traffic until the selector is deliberately changed. The incorrect choices fail for the following reasons. B. Always use latest routes traffic to the newest version and violates the release control requirement. C. Deleting test versions is unnecessary and removes version history rather than controlling production routing. D. A separate project is not required merely to prevent a new agent version from receiving production traffic. Remember this distinction for the exam. Agent versions are immutable. Production stability comes from controlling which version the stable endpoint serves. Question number 93. We are moving to hosted agent secrets. A hosted Foundry agent must call Azure resources and a third-party service. Security review prohibits secrets in the container image and prohibits storing raw secrets in environment variables. Which two approaches should you use? Select 2. Identify all valid responses. The options are: Option A. Use managed identities and Foundry connections where supported. Option B. Store required secrets in a managed secret store such as Azure Key Vault and reference them through a supported connection. Option C. Bake the third-party API key into the container image so every version has the same value. Option D. Place the API key in a plaintext environment variable in the hosted agent version. Option E. Write the API key into the agent system instructions so tools can read it. The correct answers are Option A. Use managed identities and Foundry connections where supported, and Option B. Store required secrets in a managed secret store, such as Azure Key Vault, and reference them through a supported connection. Hosted Agent Guidance recommends managed identities and connections for supported access patterns and a managed secret store, such as Key Vault for secrets that must be retained. The remaining options are incorrect because C. Secrets should not be embedded in container images. D. Hosted Agent Guidance specifically warns against putting secrets directly in environment variables. E. Prompts and instructions are not secret stores and can expose credentials to model context or telemetry. A useful examination rule is this: keep credentials out of images, prompts, and plaintext environment variables. Prefer identity and manage secret stores. Question number 94. Requires careful analysis. Identify the decisive requirement in this scenario. A hosted agent exposes the responses protocol. A client wants the next turn to continue directly from the immediately preceding response. The client does not need to reuse a persistent hosted sandbox file system and does not need an independently managed conversation object. Which request field should the client use on the next response's request? Eliminate any option that fails a requirement. Consider Option A, previous_response_ID. Consider Option B, semantic configuration. Consider Option C, tool_choice. Consider Option D, deployment_type. The appropriate choice is option A, previous underscore response underscore ID. This is correct because the response's protocol supports continuing a multi-turn interaction by passing the prior response identifier in previous underscore response underscore ID. B. Semantic configuration is an Azure AI search concept and does not chain responses API turns. C. Tool underscore choice controls tool use behavior, not conversational response chaining. D. Deployment underscore type controls model deployment characteristics, not conversation state. Keep this examination point in mind. Use previous underscore response underscore ID for direct response chaining. Use a conversation when you need a durable conversation container. Now consider question number 95. Next, we enter the topic of automation tool selection. Consider this scenario. A Foundry engineering team must automate 3 external interaction patterns while choosing the narrowest appropriate tool. Match each requirement to the most appropriate integration. Review the items in the left column. Left item 1. Automate a web-only workflow through browser pages and DOM-based interaction. Left item 2. Interact with a desktop application by interpreting screenshots and proposing mouse or keyboard actions. Left item 3. Call a structured REST service that publishes an open API specification. Choose matches from the following right side entries. Choice A on the right, browser automation tool. Choice B on the right, computer use tool. Choice C on the right, open API tool. The correct pairings are: the correct match for automate a web-only workflow through browser pages and DOM-based interaction is browser automation tool. The correct match for interact with a desktop application by interpreting screenshots and proposing mouse or keyboard actions is computer use tool. The correct match for call a structured REST service that publishes an open API specification is open API tool. The key reason is browser automation is designed for web interactions. Computer use operates from screenshots and virtual input actions, and open API tools invoke structured HTTP AP is described by an open API contract. Exam tip: choose DOM/browser automation for web UI, computer use for pixel-based desktop interaction, and open API for structured services. Let us examine question number 96. Begin by examining the scenario. A Foundry agent must integrate 3 Azure Functions workloads with different execution patterns. Match each workload to the most appropriate integration pattern. The source items are as follows. Source item 1. A reusable synchronous function service should expose tools through an industry-standard agent protocol. Source item 2. A long-running function should process work asynchronously with resilient message delivery and retries. Source item 3. An existing HTTP trigger function should be invoked from a published API contract. Match the source items to these destinations. Destination option A. Function hosted MCP server. Destination option B. Azure Q storage-based tool integration. Destination option C. Open API tool. Destination option D. File search tool. Map a reusable synchronous function service should expose tools through an industry-standard agent protocol to function hosted MCP server. Map a long-running function should process work asynchronously with resilient message delivery and retries to Azure Q storage-based tool integration. Map an existing HTTP trigger function should be invoked from a published API contract to Open API tool. The requirement is satisfied because MCP is appropriate for reusable synchronous tool exposure. Q-based integration suits asynchronous reliable processing, and an HTTP function can be exposed to an agent through its Open API description. Match tool integration to execution semantics, synchronous protocol, asynchronous queue, or structured HTTP contract. Question number 97 highlights an important distinction. This is a hard-level item, so avoid choosing too quickly. Focus on the following situation. A team is designing several multi-agent workflows with different control flow requirements. Match each requirement to the most appropriate orchestration pattern. Begin with the following left side entries. Left side entry 1. Specialists must run one after another in a fixed order. Left side entry 2. Independent specialists should run at the same time to reduce latency. Left side entry 3. The active specialist should transfer full task ownership to another specialist based on context. Left side entry 4. A manager should dynamically plan and coordinate specialists for an open-ended complex task. The second set contains right side entry A, sequential, right side entry B, concurrent, right side entry C, handoff, Right side, entry D, Magentic. Here are the completed matches. Pair specialists must run one after another in a fixed order and sequential. Pair-independent specialists should run at the same time to reduce latency and concurrent. Pair the active specialist should transfer full task ownership to another specialist based on context and handoff. Pair A manager should dynamically plan and coordinate specialists for an open-ended complex task and Magentic. The reasoning is as follows. Sequential enforces order. Concurrent parallelizes independent work. Handoff transfers control between specialists, and Magentic uses manager-driven coordination for open-ended tasks. The key takeaway is pick the simplest orchestration pattern that matches the required control flow and ownership model. Question number 98. Review the situation. A Foundry agent must delegate a task to an independently hosted specialist agent exposed through an agent-to-agent compatible endpoint. The specialist is managed separately and should be treated as a remote agent service rather than as a local function. What should you configure in the Foundry project? Choice A. An agent-to-agent, A2A, connection and A2A tool that targets the specialist agent endpoint. Choice B. A file search vector store containing the specialist agent's source code. Choice C. A custom text block list containing the specialist agent name. Choice D. A speech synthesis connection to the specialist endpoint. In this case, select option A. An agent-to-agent, A2A, connection and A2A tool that targets the specialist agent endpoint. Here is the technical justification. Foundry supports connecting to remote agent-to-agent endpoints through a project A2A connection and an A2A tool definition. The alternatives can be eliminated because B. File search retrieves document content and does not invoke a remote agent protocol endpoint. C. A block list is a safety control and does not provide agent-to-agent communication. D. Speech synthesis is unrelated to remote agent delegation. Remember this distinction for the exam. Use A2A when the dependency is another independently addressable agent rather than a normal API or local tool. The next item is question number 99. Scenario. A sandboxed application integrates the Foundry computer use tool. The model does not directly control the machine. The application must execute proposed actions and continuously return the updated visual state. Arrange the actions in the correct repeating interaction order. The available items are: Entry 1. Capture the updated environment as a new screenshot. Entry 2. Execute the proposed action in the sandboxed environment. Entry 3. Send a request that includes the computer use tool and the current screenshot or display state. Entry 4. Receive the model response containing a proposed computer action. Entry 5. Send the updated screenshot or action result back as tool call output. The completed sequences. The first item is send a request that includes the computer use tool and the current screenshot or display state. The second item is receive the model response containing a proposed computer action. The third item is execute the proposed action in the sandboxed environment. The fourth item is capture the updated environment as a new screenshot. The fifth item is send the updated screenshot or action result back as tool call output. Computer use follows an application-mediated loop. Provide the current screen, receive an action, execute it externally, capture the new state, and return that state for the next decision. A useful examination rule is this. The model proposes actions, your application executes them, and supplies the next screenshot. Let us examine question number 100. Begin by examining the scenario. A web client invokes a hosted Foundry agent through the responses protocol and must display generated text incrementally rather than waiting for the full response. Which two implementation choices are required? Select 2. Select all answers that apply. Compare the following options. Option A is set streaming on the responses request. Option B is process incremental response events, such as output text delta events, until the response completes. Option C is create a new model deployment for every emitted token. Option D is use Azure AI search semantic answers as the transport protocol. Option E is disable all agent tools because streaming and tools cannot coexist. Select Option A, set streaming on the responses request, and Option B, process incremental response events such as output text delta events until the response completes. This is correct because streaming requires the request to enable streaming and the client to consume the server-sent incremental response events until completion. The other choices do not satisfy the requirement because C. Streaming tokens does not require separate model deployments. D. Semantic answers are Azure AI search response content, not the hosted agent streaming transport. E. Streaming does not inherently require removing agent tools. Keep this examination point in mind. Streaming changes how response events are delivered. It does not change the deployment for each token. We will now analyze question number 101. The focus now shifts to image output controls. Review the scenario carefully. A design service uses a supported GPT image model. It needs a logo asset with no opaque background and wants progressive visual feedback while the image is being generated. Complete the image generation request. The first statement reads, set background to the blank. Select from 1. Transparent, opaque, or auto only. The second statement reads, use the blank as the output format for the transparent background request. Select from 2. PNG, plain text, or MP3. The third statement reads, to receive partial images during generation, set stream to the blank. Select from 3. True, false, or null only. For statement 1, select transparent. The background control requests transparency rather than an opaque generated background. For statement 2, select PNG. PNG supports the transparent background workflow documented for GPT image generation. For statement 3, select true. Partial image delivery is a streaming feature, so stream must be enabled. Exam tip. Image output controls affect format and delivery. Transparency and partial image streaming require explicit request settings. Review question number 102. Carefully. Let us first review the situation. A Python service must modify an existing product photograph with a GPT image deployment. The request supplies the source image file and a text instruction but does not need to create an image from text alone. How should the service submit the request? Review each available choice. Choice A. Call the image edits endpoint using multipart/form data with the source image and prompt. Choice B. Call an embeddings endpoint with the image bytes converted to a vector. Choice C. Call the text completions endpoint and place the binary image inside a system message. Choice D. Call Azure AI search and store the image as the semantic configuration. The appropriate choice is option A. Call the image edits endpoint using multipart/form data with the source image and prompt. The key reason is the GPT image editing workflow uses the image edits API and multipart/form data, so the source image and text prompt can be submitted together. Now consider why the remaining options are unsuitable. B. Embeddings support similarity and retrieval, not image modification. C. A text completion request is not the supported image edit transport. D. Azure AI search does not perform prompt-driven image editing. Generation starts from a prompt. Image editing sends source media plus instructions to the image edit API. The next key item is question number 103. Take extra care here because this is a hard question. The central scenario is as follows. A service generates videos with Sora 2 through the asynchronous video generation API. Arrange the actions in the correct order. Build the sequence from the following entries. The first available item is download the generated video content by using the successful generation identifier. The second available item is create a video generation job and capture its job identifier. The third available item is poll the job status endpoint until the job succeeds, fails, or is canceled. The fourth available item is read the successful job result to obtain the generated video identifier. Here is the proper order. First, create a video generation job and capture its job identifier. Second, poll the job status endpoint until the job succeeds, fails, or is canceled. Third, read the successful job result to obtain the generated video identifier. Fourth, download the generated video content by using the successful generation identifier. The requirement is satisfied because Sora video generation is asynchronous. Create the job, monitor status, obtain the resulting generation ID after success, and then retrieve the MP4 content. The key takeaway is treat video generation as a job lifecycle, not a single synchronous inference call. Proceed to question number 104. A Sora 2 application must generate an 8-second landscape clip using currently supported standard render settings. Complete the video request. For the first statement, set size to the blank. The available choices are 1. 1280 by 720, 720 by 1280, or 1024 by 1024. For the second statement, set seconds to the blank. The available choices are 2, 8, 7, or 30. Statement 1 should be completed with 1280 by 720. 1280 times 720 is the documented landscape output size. Statement 2 should be completed with 8. 8 seconds is one of the documented Sora 2 duration choices. Remember this distinction for the exam. For Media AP is, distinguish creative prompt content from model-specific render controls such as size and duration. Proceed to question number 105. The focus now shifts to image analysis design. Consider this scenario. An enterprise has 3 image workloads and wants the most appropriate Microsoft Foundry capability for each. Match each workload to the best approach. Review the available source items. The first source item is extract repeatable structured fields such as defect category and defect severity from thousands of factory images. The second source item is answer an ad hoc technician question about what is visible in a single uploaded image. The third source item is create a new marketing image from a written campaign brief. Now review the available destinations. Destination A, Custom Content Understanding Image Analyzer. Destination B, Vision-Capable Multimodal Model. Destination C, Image Generation Model. Destination D, Azure AI Search Semantic Ranker. For mapping 1, pair extract repeatable structured fields such as defect category and defect severity from thousands of factory images with custom content understanding image analyzer. For mapping 2, pair answer an ad hoc technician question about what is visible in a single uploaded image with vision-capable multimodal model. For mapping 3, pair create a new marketing image from a written campaign brief with image generation model. The reasoning is as follows. Content understanding is suited to reusable schema-based extraction at scale. A multimodal model handles ad hoc visual reasoning, and an image generation model creates new visual media. A useful examination rule is this. Separate structured extraction, visual reasoning, and media generation. They solve different computer vision problems. Let us work through question number 106. Consider the following scenario. A team is deciding when to use content understanding image analysis versus document-oriented extraction. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. A custom image analyzer is appropriate when the primary requirement is structured extraction of visual properties, such as product counts or manufacturing defects. Statement 2. For a text-heavy scan form where the main goal is OCR, fields, and layout, an image analyzer should always be preferred over a document field extraction schema. Statement 3. A reusable image analyzer can define fields and descriptions so image results are returned in a consistent structured form. For the first statement, choose yes. Content understanding image analyzers support schema-based structured extraction from images. For the second statement, choose no. Microsoft guidance notes that image analyzers are not optimized when analysis is primarily extracted text. Document-oriented field extraction is more appropriate. For the third statement, choose yes. Custom analyzer schemas define the structured fields expected from each analyzed image. Keep this examination point in mind. Use image analyzers for visual extraction. Use document extraction when OCR and document structure dominate. Let us work through question number 107. We are moving to speech transcription modes. Let us first review the situation. A media platform has 3 speech-to-text workloads with different latency and scale requirements. Match each workload to the most appropriate speech capability. The first set contains Item 1 on the left. Display text continuously while a customer is still speaking. Item 2 on the left. Transcribe a completed recording synchronously and faster than real time. Item 3 on the left. Process a large collection of recordings in storage asynchronously. The right side choices are right option A, real-time speech to text. Right option B, fast transcription. Right option C, batch transcription. Use the following matching result. Match display text continuously while a customer is still speaking with real-time speech to text. Match transcribe a completed recording synchronously and faster than real-time with fast transcription. Match process a large collection of recordings in storage asynchronously with batch transcription. Here is the technical justification. Real-time STT handles live streams. Fast transcription handles pre-recorded files with predictable fast synchronous results, and batch transcription processes large stored workloads asynchronously. Exam tip. Choose transcription mode by input state and latency target, live stream, fast file, or large asynchronous batch. Review question number 108. Carefully. Consider the following scenario. A compliance archive submits recorded meetings to Azure Speech Batch Transcription. Reviewers need to distinguish speakers and align specific spoken words with timestamps. Which two transcription options directly support the requirements? Select 2. Choose every option that satisfies the requirement. Compare the following options. Choice A. Enable diarization. Choice B. Enable word-level timestamps. Choice C. Enable image input fidelity. Choice D. Configure an Azure AI search vectorizer. Choice E. Enable video remix. The required selections are Option A, enable diarization, and Option B, enable word-level timestamps. Diarization identifies speaker turns, while word-level timestamps provide timing information for recognized words in supported batch transcription configurations. The incorrect choices fail for the following reasons. C. Image input fidelity is an image generation setting. D. A search vectorizer creates embeddings for vector queries and does not add speech timing or speaker labels. E. Video remix edits generated video and is unrelated to speech transcription. Speech transcription options enrich recognition output. They are separate from search, image, and video generation settings. The next item is question number 109. This question moves us into speech synthesis, SSML. A text-to-speech application must precisely pronounce an uncommon chemical name, apply a reusable pronunciation dictionary for many domain terms, and slow one sentence for emphasis. Complete the SSML design. Statement 1. For phonetic pronunciation of one specific word, use the blank element. Choose between 1. Phoneme, audio, or bookmark. Statement 2. For reusable pronunciation mappings across many terms, use the blank. Choose between 2. Custom lexicon, vector index, or content filter. Statement 3. For speaking rate control on the emphasized sentence, use the blank. Choose between 3. Prosody, prompt shields, or diarization. The correct value for statement 1 is phoneme. The phoneme element supplies a phonetic representation for exact pronunciation. The correct value for statement 2 is custom lexicon. A custom lexicon avoids repeating pronunciation rules for a reusable domain vocabulary. The correct value for statement 3 is prosody. The prosody element adjusts speaking rate, pitch, volume, and related synthesis characteristics. The key takeaway is use SSML for synthesis control, phoneme for a term, lexicon for vocabulary, and prosody for speaking style. Let us examine question number 110. Begin by examining the scenario. A translation service has 2 document workloads. One request translates a single document and must return the translated file directly without requiring blob storage. Another translates hundreds of documents stored in containers and should preserve document structure and formatting. Select the appropriate translator capability for each workload. Review each blank and choose the most appropriate option. The first statement reads, for the single-file direct response workflow, use the blank. Choose between 1. Synchronous document translation, batch transcription, or real-time speech translation. The second statement reads, for the large container-based workload, use the blank. Choose between 2. Asynchronous batch document translation, text-to-speech, or image generation. Statement 1 should be completed with synchronous document translation. Synchronous document translation does not require a blob storage batch workflow for a single file. Statement 2 should be completed with asynchronous batch document translation. Asynchronous document translation is the batch-oriented service for translating many files from storage. Remember this distinction for the exam. Translator text, synchronous document, and batch document translation differ mainly by payload shape and workflow scale. Now consider question number 111. This is a harder question, so check every requirement carefully. Scenario: a manufacturer needs a domain-adapted speech-to-text model for specialized equipment terminology and must expose the selected model to a production application. Arrange the major custom speech lifecycle actions in the correct order. Review the items to be ordered. Item 1. Deploy the selected custom model to a custom endpoint. Item 2. Create the custom speech project. Item 3. Train a custom speech-to-text model using the prepared data. Item 4. Upload or connect the domain-specific training and evaluation data. Item 5. Evaluate or compare the custom model's recognition accuracy before deployment. Arrange the items in this order. In position 1, create the custom speech project. In position 2, upload or connect the domain-specific training and evaluation data. In position 3, train a custom speech-to-text model using the prepared data. In position 4, evaluate or compare the custom model's recognition accuracy before deployment. In position 5, deploy the selected custom model to a custom endpoint. This is correct because custom speech development starts with a project and data, then trains a model, validates recognition quality, and finally deploys the selected model to an endpoint. A useful examination rule is this: treat custom speech as a model lifecycle: project, data, train, evaluate, deploy. We will now analyze question number 112. Review the scenario carefully. A batch processing service receives recordings in several possible locales and must configure speech language identification correctly. For each statement, select yes if the statement is true. Otherwise, select no. Review statement 1. When batch language identification is configured, candidate locales must contain a supported candidate list rather than an arbitrary free-form language description. Review statement 2. Specifying a known locale can improve recognition accuracy and reduce language detection overhead when the locale is already known. Review statement 3. Fast transcription language identification is always the best choice for a file that intentionally switches among many languages and requires multilingual transcription of all of them. Statement 1. The answer is yes. Batch language identification uses candidate locale values and documented limits for the candidate list. Statement 2. The answer is yes. Providing the known locale avoids unnecessary identification and can improve accuracy and latency. Statement 3. The answer is no. Fast transcription language identification is oriented to identifying a main locale. Explicitly multilingual transcription is more appropriate when a file contains multiple languages. Keep this examination point in mind. Use language ID when the language is uncertain. Use multilingual transcription when the audio intentionally contains multiple languages. Let us work through question number 113. Next, we enter the topic of integrated vectorization. Consider the following scenario. An Azure AI search (RAG) pipeline should create embeddings automatically during indexing and also accept plain text vector queries without the application generating query vectors itself. Complete the integrated vectorization configuration. For the first statement, during indexing, generate content embeddings by using in the blank. Select from 1. Azure OpenAI embedding skill, semantic answer, or custom block list. For the second statement, at query time, convert a plain text query into a vector by using in the blank. Select from 2. Azure OpenAI vectorizer, indexer schedule, or prompt shields control. For the third statement, associate the query time vectorizer with the vector field through the blank. Select from 3. Vector search profile, speech endpoint, or content category. The answer to the first statement is Azure OpenAI embedding skill. The embedding skill produces vectors as content flows through the indexer and skill set. The answer to the second statement is Azure OpenAI vectorizer. A vectorizer generates the query embedding inside Azure AI search from a text query. The answer to the third statement is vector search profile. The vector search profile ties algorithm and vectorizer configuration to the vector field. Exam tip. Index time embedding is a skill. Query time embedding is a vectorizer referenced through the vector profile. Question number 114. Review the situation. A medical knowledge index contains vectors for many specialties. A query filters to one rare specialty, and missing a qualifying document would be unacceptable. The team can tolerate extra compute cost to maximize recall. Which vector filter mode should the query use? The options are: Option A, pre-filter. Option B, post-filter. Option C, strict post filter. Option D, no filter because vector fields cannot be combined with metadata filters. The required response is option A, pre-filter. The key reason is pre-filter applies the metadata filter during HNSW traversal and is the recommended mode when recall is critical, especially for selective filters and small candidate sets. The remaining options are incorrect because B, post-filter can produce false negatives because filtering occurs after each shard finds unfiltered vector candidates. C, strict post-filter has the highest risk of false negatives for selective filters because it filters only the global top case set. D, vector queries can use filters on suitable filterable non-vector metadata fields. For selective, recall critical vector search, prefer pre-filter even if it costs more traversal work. The next item is question number 115. Background. A company is building ARAG index from long policy documents in Azure Blob Storage. Current environment. The indexing skillset splits each parent document into many chunks. Retrieval should return chunks, but every chunk must also carry the parent title and parent identifier for citation and filtering. Business requirements. The team wants one searchable index with a uniform document shape and no extra standalone parent records that contain null chunk fields. Technical requirements. The pipeline uses an indexer and skill set with one-to-many chunking. Which index projection design should you use? Available choices. Choice A, project the chunks into one index. Repeat the required parent fields on each chunk and use skip indexing parent documents. Choice B, index only the original parent documents and discard all chunks after the text split skill runs. Choice C, use include indexing parent documents so parent and child records with different shapes are always mixed in the same index. Choice D, create a vector field with no parent identifier and reconstruct citations from the embedding values. The correct answer is option A, project the chunks into one index, repeat the required parent fields on each chunk, and use skip indexing parent documents. The requirement is satisfied because the recommended single index RAG pattern projects child chunks into one index, repeats required parent metadata on each child, and skips separate parent documents, so the index has a uniform chunk-oriented shape. B, discarding chunks defeats the chunk-level retrieval requirement. C, including parent documents creates mixed document shapes with parent rows that lack chunk fields, contrary to the stated requirement. D, embeddings do not encode a reliable parent identifier for citation or filtering. The key takeaway is index projections, shape, one-to-many chunk output. Repeating parent metadata on child chunks simplifies RAG retrieval and citations. Review question number 116. Carefully. We are moving to semantic answers. Let us first review the situation. A search application is evaluating Azure AI search semantic answers as a feature distinct from generative RAG. For each statement, select yes if the statement is true. Otherwise, select no. Review statement 1. A semantic answer is extracted verbatim from indexed content rather than newly generated by an LLM. Review statement 2. A semantic answer request requires semantic query configuration and can return an empty answers collection when no sufficiently supported answer is found. Review statement 3. A semantic answer is equivalent to ARAG response because both freely synthesize new wording from multiple retrieved documents. Statement 1 should be marked yes. Semantic answers use machine reading comprehension to extract answer-like passages that already exist in indexed text. Statement 2 should be marked yes. Semantic answers are requested as part of semantic query processing and aren't guaranteed for every question. Statement 3 should be marked no. Generative RAG can compose new language from retrieved context, whereas semantic answers return extracted source passages. Remember this distinction for the exam. Semantic answers extract. RAG generates from retrieved evidence. Let us focus on question number 117. Focus on the following situation. A content understanding pipeline must support both textual provenance and visual highlighting of extracted document elements. Match each result property or structure to what it represents. Begin with the following source items. Source 1, source. Source 2, span. Source 3, pages, paragraphs, tables, and sections. The destination requirements are as follows. Target A, visual location such as page plus bounding polygon or bounding box. Target B, logical offset and length within the top-level markdown content. Target C, structured document layout hierarchy. Target D, model deployment quota. The correct destination for source is visual location, such as page plus bounding polygon or bounding box. The correct destination for span is logical offset and length within the top-level markdown content. The correct destination for pages, paragraphs, tables, and sections is structured document layout hierarchy. The reasoning is as follows. Content understanding returns source metadata for visual location, spans for logical text position, and structural collections for document hierarchy. A useful examination rule is this. Use source for where an element appears visually and span for where it appears in the extracted text stream. Question number 118. Consider this scenario. A mortgage intake packet can contain several document types in one uploaded PDF, such as identity documents, bank statements, and tax forms. The pipeline must identify the categories and split the packet into meaningful segments before category-specific extraction. Which content understanding design best meets the requirement? Review the options. Option A. Configure an analyzer with content categories and segmentation enabled so classification and splitting occur as part of analysis. Option B. Run only a generic OCR request and infer document boundaries from blank lines. Option C. Use an image generation model to recreate each page and classify the regenerated images. Option D. Use Azure AI search semantic ranking before any document extraction or segmentation. The best answer is option A. Configure an analyzer with content categories and segmentation enabled so classification and splitting occur as part of analysis. Here is the technical justification. Content understanding analyzers can combine content classification with segmentation, allowing a mixed input packet to be categorized and split into logical document segments before downstream extraction. The alternatives can be eliminated because B. OCR alone does not provide robust document type classification and logical packet segmentation. C. Image generation changes source evidence and is not a document classification workflow. D. Semantic ranking operates over indexed content and does not replace extraction time classification and segmentation. Keep this examination point in mind. When one file contains multiple document instances, combine classification with segmentation before specialized extraction. Proceed to question number 119. Next, we enter the topic of batch model processing. Review the situation. A retailer must summarize 200,000 archived product review documents every night. The results are not interactive. Completion within several hours is acceptable, and the team wants to reduce inference cost without consuming the quota used by its real-time chatbot. Which Azure OpenAI deployment approach is the best fit? Choice A. Use a global batch or data zone batch deployment and submit the requests as a batch job. Choice B. Send all requests to the chatbot's standard deployment one at a time. Choice C. Use a provision deployment only because batch processing requires PTUs. Choice D. Increase the chatbot temperature so more reviews can be processed per request. In this case, select option A. Use a global batch or data zone batch deployment and submit the requests as a batch job. Azure OpenAI Batch is designed for large asynchronous workloads, uses separate batch quota, and is cost-optimized for high-volume processing that does not require interactive latency. The other choices do not satisfy the requirement because B. Using the real-time deployment for a large offline workload can consume online quota and provides no batch cost advantage. C. Provision throughput is intended for predictable online throughput. It is not required for batch API jobs. D. Temperature changes sampling behavior and does not increase batch capacity. Exam tip. Use batch for large offline workloads. Use standard or provisioned when interactive latency matters. Now consider question number 120. Scenario. A development team is searching the Microsoft Foundry model catalog for a model that must support tool calling and must also be available through a standard deployment. Which two model catalog filters are most directly relevant? Select 2. Select all answers that apply. Option A. Capabilities. Option B. Deployment options. Option C. License only. Option D. Existing deployments only. Option E. Industry only. The choices that satisfy the requirement are option A, capabilities, and option B, deployment options. This is correct because the capabilities filter can narrow models by features such as tool calling, while deployment options filters models by supported hosting choices such as standard, provisioned, batch, or managed compute. Now consider why the remaining options are unsuitable. C. License information can be important legally, but does not directly determine tool calling support or standard deployment availability. D. Existing deployments shows already deployed models rather than catalog capability requirements. E. Industry filtering narrows domain-oriented models, but does not directly enforce the two stated technical requirements. Filter models first by required capability and deployment support, then compare quality, cost, and licensing. Proceed to question number 121. The focus now shifts to search read-only, or BAC. A Foundry application uses a managed identity to query an existing Azure AI search index. The application must read search results, but must not upload documents or modify index content. Which Azure AI search role should you assign to the managed identity? Available choices. Choice A, Search Index Data Reader. Choice B, Search Index Data Contributor. Choice C, Search Service Contributor. Choice D, Owner. The required response is option A, Search Index Data Reader. The key reason is Search Index Data Reader grants read-only data plane access for querying search indexes without granting document write permissions. The incorrect choices fail for the following reasons. B. Search Index Data Contributor includes read-write access to index documents and exceeds the requirement. C. Search Service Contributor is a control plane role for managing search resources and is broader than read-only query access. D. Owner provides broad resource and access management privileges and violates least privilege. The key takeaway is for query-only search access. Use Search Index Data Reader. Use Data Contributor when documents must be loaded or updated. Question number 122. Consider this scenario. A team wants repeatable deployment of its Microsoft Foundry solution across development, test, and production environments. For each statement, select yes if the statement is true. Otherwise, select no. Statement 1. Keeping infrastructure definitions and deployment parameters in source control helps make environment creation repeatable. Statement 2. A CI/CD pipeline can deploy infrastructure and application artifacts instead of relying only on manual portal changes. Statement 3. Using CI/CD means model availability and regional quota no longer need to be validated in the target environment. Statement 1 should be marked yes. Source-controlled infrastructure as code and configuration support repeatable environment promotion. Statement 2 should be marked yes. Automated pipelines can deploy Azure infrastructure and application artifacts consistently across environments. Statement 3 should be marked no. Automation does not override model availability, regional support, quota, or capacity constraints. Remember this distinction for the exam. Automation standardizes deployment. It does not remove Azure region, model, or quota constraints. The next item is question number 123. Treat this as a medium question. Scenario. A company creates a custom Azure OpenAI content filter configuration with stricter thresholds than the default. The same configuration must protect two model deployments. Complete the configuration steps. Review Statement 1. Create the custom filtering rules as of the blank. The options for this statement are 1. Content filter configuration, vector search profile, or speech project. Review Statement 2. Associate that configuration with the blank. The options for this statement are 2. Each model deployment that should use it, only the Foundry project name, or the Azure subscription billing profile. For Statement 1, select Content Filter Configuration. The custom safety thresholds belong in a content filter configuration rather than in a search or speech object. For Statement 2, select each model deployment that should use it. The filter takes effect on the deployments to which it is assigned. A useful examination rule is this. Define safety behavior in a filter configuration, then attach that configuration to the deployments that need it. Now consider question number 124. A production application uses a Foundry model version that has entered a deprecated lifecycle stage. Microsoft lists a retirement date and a suggested replacement model. What should the team do? The options are: Choice A, deploy and evaluate the suggested replacement, then migrate production traffic before retirement. Choice B. Ignore the lifecycle status because deprecated models continue indefinitely. Choice C. Delete the current deployment immediately without testing a replacement. Choice D. Increase the current deployment quota so the retirement date is extended. The appropriate choice is option A. Deploy and evaluate the suggested replacement, then migrate production traffic before retirement. The requirement is satisfied because deprecated models can continue working for a limited period, but teams should evaluate the suggested replacement and migrate before the retirement date. The remaining options are incorrect because B. Deprecated models have a defined life cycle and do not continue indefinitely. C. Immediate deletion creates unnecessary downtime and skips replacement validation. D. Quota changes do not extend a model's life cycle or retirement date. Keep this examination point in mind. Treat deprecation as a migration window. Test the replacement before the old model reaches retirement. Proceed to question number 125. This question moves us into code interpreter files. Review the situation. A finance agent receives a user-uploaded CSV file. It must calculate monthly totals, perform a correlation analysis, and generate a chart during the conversation. Which agent tool is the best fit? Review the options. Option A, Code Interpreter. Option B, File Search. Option C, Prompt Shields. Option D, Grounding with Bing Search. The best answer is option A, Code Interpreter. The reasoning is as follows. Code Interpreter provides a sandboxed Python environment for calculations, data analysis, and visualization over uploaded files. B. File Search retrieves relevant passages from files, but is not intended for arbitrary Python calculations and chart generation. C. Prompt Shields is a safety control and does not analyze tabular data. D. Bing Grounding retrieves public web information rather than executing analysis on the uploaded CSV. Exam tip. Use File Search to retrieve file content. Use Code Interpreter when the agent must compute, transform, or visualize data. Apply precise reasoning to question number 126. Pay close attention to every stated constraint. An HR agent must answer questions from private policy documents already stored in the organization's SharePoint environment. The team wants the agent to use a supported Foundry knowledge integration instead of copying every document into a new upload store. Which tool should you configure? Evaluate each option against the stated requirement. Next, option A, SharePoint tool. Next, option B, computer use tool. Next, option C, image generation tool. Next, option D, speech translation. The correct answer is option A, SharePoint tool. Here is the technical justification. The SharePoint tool grounds agent answers in SharePoint content that is accessible through a configured Foundry SharePoint connection. The alternatives can be eliminated because B, computer use automates user interfaces and is not the dedicated SharePoint knowledge grounding integration. C, image generation creates visual media and does not retrieve SharePoint documents. D, speech translation handles spoken language translation and does not provide SharePoint retrieval. When enterprise knowledge already lives in SharePoint, use the dedicated SharePoint grounding integration. We will now analyze question number 127. This question moves us into Fabric Data Agent. Review the scenario carefully. A sales support agent must answer natural language questions over business data already exposed through a Microsoft Fabric Data Agent. Which Foundry agent tool should you use? Choose from the following options. Option A is Microsoft Fabric Tool. Option B is File Search Tool. Option C is Image Moderation. Option D is Custom Speech. In this case, select option A, Microsoft Fabric Tool. The Microsoft Fabric Tool connects a Foundry agent to a Microsoft Fabric Data Agent, so the agent can reason over and answer questions from Fabric data. The other choices do not satisfy the requirement because B, File Search is designed for document retrieval rather than connecting to a Fabric Data Agent. C, Image Moderation classifies visual safety content. D, Custom Speech adapts speech recognition and is unrelated to Fabric data. The key takeaway is use the Fabric tool when the knowledge source is a Microsoft Fabric Data Agent. Now consider question number 128. Consider this scenario. A Foundry agent uses an open API tool to call an Azure-hosted business API. The API accepts Microsoft Intra tokens, and the organization prohibits stored API keys. Complete the authentication design. Statement 1. Configure the Open API tool to use the blank authentication. The available choices are 1. Managed identity, API key, or anonymous. Statement 2. Grant the agent identity the blank on the target API or protected resource. The available choices are 2. The least privilege role or permission required by the API, storage blob data contributor automatically, or owner on the entire subscription. The correct value for Statement 1 is Managed Identity. Managed Identity provides keyless Microsoft Intra authentication for supported Open API integrations. The correct value for Statement 2 is the least privilege role or permission required by the API. Authentication identifies the caller. Authorization must still grant only the permissions required by the target API. Remember this distinction for the exam. Keyless authentication still needs authorization. Identity proves who the caller is. Our BAC or permissions define what it may do. You have completed Set 3 of the AI-103, Microsoft Certified AI Engineer Associate, Practice Question Series. How did you score? Share your result in the comments. Work through all the sets to build broader exam readiness and cover more practice questions. Please like this video, subscribe to Tech with Koushik, and enable notifications for more certification exam preparation content. Thank you for watching, and I will see you in another practice set.